For this question, you're asked how many atoms of titanium do you have in 10.0 grams of titanium. And for this, we're going to need a few different things. We're going to need to know Avogadro's number, which is depicted here, and that's 6.022 times 10 to the 23rd something per mole. And it's a way that we keep track of really large quantities in chemistry and the physical sciences. So if we have 6.022 times 10 to the 23rd atoms in a single mole, then first we need to find out how many moles of titanium is present in 10.0 grams. And for that, we're going to need the conversion factor of our molar mass. And for titanium, if you went to the periodic table and found the number underneath the atomic symbol, you would find 47.9 grams per mole. This means that in titanium, in 1 mole, there's 47.9 grams of titanium. So now, we can use all of these values to go from grams of titanium to atoms of titanium. So, we'll start with what we know with certainty, and we're going to set this up the same way we've been doing in this class, and that's using the factor label or dimensional analysis approach. So if I have 10.0 grams titanium, that's what I know with certainty. And then what I want to find eventually at the end is how many atoms of titanium. So now I can use these values, my molar mass, even Avogadro's number, as conversion factors to get there. So I'm going to set it up the same way I always do. And I want to cancel out grams. And the value that will allow me to cancel out grams is the molar mass, where I'm going to need to put grams in the denominator in order to cancel it out. And the only way to do that is by flipping the molar mass, where I put 1 mole here, and I put 47.9 in the denominator. Because remember, in 1 mole, there's 47.9 grams of titanium. So from there, I cancel out my grams of titanium, and what I'm left with in the numerator is moles. But my final answer needs to be atoms. So I'm going to use Avogadro's number, which is 6.022 times 10 to the 23rd atoms per mole, to cancel that out. So I'm going to put 6.022 times 10 to the 23rd atoms for every 1 mole. And now, what you should notice is that moles cancel out, and all that you're left with is atoms of titanium. So I know that if I plug this into my calculator correctly, I'm going to get the right answer. So if I did that, if I went into my calculator and I put 10.0 grams divided by 47.9 times 6.022 times 10 to the 23rd atoms, then what your calculator should spit out to you is a value that looks something like 1.257.205, etc. times 10 to the 23rd. So if your calculator says 1.257205 or something like that times 10 to the 23rd atoms, then you've done it correct. But that's not it. What we need to do is also keep track of our significant digits. There are 3 significant digits in 10.0, 3 here, and 4 here. And because all we did was multiply and divide, then we need to keep track of our sig figs. So we should report 3 significant digits in our final answer, which is going to be right here, where the 1, the 2, the 5 are all significant. And because the following number is greater than 5, then I'm going to round up this value. So my final answer that I would report here, keeping track of sig figs, would be 1.26 times 10 to the 23rd atoms of titanium. Now, some people have been asking about how to plug this into your calculator. So anytime you have scientific notation, the way that you would plug this value in would be by putting 6.022 and then hitting the EE button on your calculator and then putting in 23. And you should see this reported, your final answer, as 1.26 EE 23. Because what that EE is telling you is like saying times 10 to the. So 1.26 times 10 to the 23rd. And when you plug it in to use it as part of your calculation, you put in 6.022 times 10 to the 23rd by plugging in this EE value.